Okay, so if I can share my screen. So do you see the maple screen?
Yes.
Okay, so here's problem one. The differential equation was dy dx equals 6xy.
Yeah, to find the general solution.
So this is how, so I'm recording this or saving this as ODE. I could call it anything I like, but I called it ODE. And this is the syntax, right? This is dy dx. Exactly. I mean, this is, you can't invent something else. This is what Maple uses. And then once you have the ordinary differential equations, the command dsolve, this ODE, gives you the general solution. This means e to the 3x squared times some constant C1. This just means an arbitrary constant.
Oh, like the plus C.
So this is like, well, it's not a additive constant, it's a multiplicative constant.
Oh, okay.
Okay. So that's how you find the general solution to a differential equation. So
Okay.
suppose you have a differential equation with an initial condition. So that's what's in problem 2.
Okay.
So in this case, the ODE, I don't have to call it that. It's
Yeah,
just,
that's just the term that you want to use. You can name it anything.
yeah, I can call it George. I mean, anything.
Yeah.
So it's the derivative expressed like this, differential derivative of y of x with respect to x. If I put in one x, it's the first derivative. If I were to put in two x's, that would be a second derivative, which I needed in a later problem, but not this problem.
Yeah,
And
that's
this differential equation is dy dx equals x squared times y cubed.
yeah.
So that's my equation.
And then
And
you'll
again, I can
desolve.
use anything for initial conditions. I'm using ICS just because
Okay.
that's what Maple does in it. If you go to help, the initial condition is that the value of the function at 1 is equal to 2. So now I want to solve with this initial condition, the differential equation, and I put them in curly brackets. Oops.
Oh, you messed up a little bit.
What did I mess up?
I don't know if you desolve. There was a new update, so for the math lab, so I don't know if that's what's causing this.
No, it should work. Let's see. So this is the differential equation, x squared y cubed. Suppose I didn't have the initial condition. Huh. Why does it feel like that? Let me
I think
just,
it could be having a problem where you have to just exit and go back in.
let's see. So here, it works. So if it works there,
Sometimes you have to close that.
oh, I know my mistake. I can't write y, it's y of x.
Oh,
That's my mistake.
oh yeah. Because in
So
div you
here
put
I
y of
get
x.
this is a general solution. But if I want a solution satisfying the initial condition, that's it. So if you plug in y equals 1, you get the square root of 9, which is 3 in the denominator, and 6 over 3 is 2.
Okay. Now I'm understanding it now. Because I remember doing this in class not that long ago. I think we did it last week in my actual calculus 2 class.
Right. Well, all of these problems you can solve by separation of variables. At least the one, we only have the first derivative. Let's see, let me try and do number 3.
Number 3 is 0.2 for y of 0.
So here, the differential equation is derivative of y of x with respect to x equals y of x times 1 minus y of x. dy dx is y times 1 minus y. The initial condition is y of zeros equals 4. Oops.
Oh, Professor, I have quick question. Are we gonna have like a final exam review sheet? They're gonna
Yes.
up like next week?
Yeah.
Okay. I'll make sure.
Mhm. So let me just jump to problem 5, because that involves a second order differential equation. So in this case, it's the second derivative plus 7 times the first derivative
Yep, first derivative plus 10y equals 0.
plus 10 times y of x equals 0. So first derivative, second, 7 times the first, okay. And I don't have an initial condition, so I just want to find the general solution. And this says there are two different solutions, e to the minus 5x, e to the minus 2x, and then a linear combination of them. This is C1, this is one constant. This is any other constant, C2. So any expression of this form is also a solution.
Okay.
And finally, let's see. Problem 6. So in this case, my differential equation is the second derivative plus 6 times the first derivative plus 9 times the second. And my initial conditions, let's see, I'm not sure how to write this, so I'll try something and then I'll try something else if this doesn't work.
Okay.
If this doesn't work, I'll just go to help and see how they do it.
All right.
So this is just a matter of getting the syntax right.
Yeah.
Desolve. So, oh, so here they use capital D of Y. So let's try that.
That's another way of doing derivative. So Russell, you can use, let's say, because I know you use diff to find the derivative, but let's say when I did finding derivative, I just did capital D instead.
If it were, I mean, often many things will work and many things won't work. So the first derivative in this problem is 0, and the second derivative is 2. Okay. Wait, that's not right. There we are. Yep. So the two basic solutions to this differential equation are e to the minus 3x and x times e to the minus 3x. And this particular linear combination is 1 at 0 and 2 when you evaluate the derivative at 0. Yeah.
Okay.
Maybe just for completeness, because I'm going to post this. Let me put in problem 4. So everything is here.
Problem number 4 is with sine.
So this is dy dx. Problem 4 plus y of x
Equals sine squared
equals
x.
sine of x. Just do it like this to make sure there's no ambiguity. So dy dx plus y of x equals sine squared x. And the initial condition is y of 0 is 0.2. And solution looks like that. So that seems to be how you solve these ordinary differential equations in Maple.
Okay.
Doing
Thank
it by hand is always a lot of work. This is an incredibly
Easy.
valuable resource.
Yeah.
You actually have to solve differential equations for some reason.
Yeah, I know like there's usually like 6 steps like for doing each of these questions with Maple. It's a lot easier just to plug it in and find it. So,
Okay.
yeah.
Anything
thank
else
you.
I can do for you?
That's it. I just wanted to understand exactly how to do these problems for the homework, but thank you, Professor.
Okay, glad to help. Take care.
You too.
All right, bye-bye.